So we're going to review all about functions. We're going to start out with transformations of functions. So these are all of your rules, but remember, if it's multiple choice, you can use your calculator. And if it's free response, you can use your parent function and your transformed function in the calculator to help you figure out the direction in case you forget any of these rules. But plus k and minus k on the outside is up and down, and it's the same. So plus k means up k units, minus k is down k units. Inside is left and right. So plus k on the inside, remember that inside is always opposite also. So plus k means we are moving left k units, and minus k means we are moving right k units. A negative is a reflection, and depending on whether it's the outside or the inside tells me what we're doing. So outside is up and down, which means that since my negative is on the outside, I'm flipping vertically. So it's a reflection over the x-axis. Inside means I'm moving horizontally, left to right. So I have a reflection over the y-axis. And then k in the front is a vertical stretch or shrink. If k is bigger than 1, it's a stretch. If k is between 0 and 1, it's a shrink. So those are our transformations of functions. So now key features of a graph. So domain is the x values, which means that we look at a graph from left to right. The range is your y values. And on a graph, we look from bottom to top. Infinity and asymptotes are always going to get parentheses when we are writing domain or range. And just a couple of things to remember that come up often. All real numbers, sometimes they put in words. The symbols for that is negative infinity to positive infinity. Positive real numbers, they write in words sometimes, and that just means 0 to infinity. And then obviously negative real numbers, because sometimes they give us these multiple choice questions and they use symbols, and sometimes they give us these multiple choice questions and they use English words, descriptions. All right, so intercepts, it's when it touches or crosses an axis. But remember that sometimes they give us an equation, sometimes they give us a table, sometimes they give us a graph. So your x-intercept is when y equals 0. So it's always going to be a number, comma 0. And in a table, I'd be looking for when y is 0. The y-intercept is the opposite. It's when x equals 0. So it's going to be 0, comma, a number. And in a table, I'm looking for when x is 0. End behavior. Your setup is as x goes to infinity, f of x goes to, and then you fill in the blank. And as x goes to negative infinity, f of x goes to blank, and you're going to fill it in. Remember, here's my graph. This is my x-axis. So positive infinity This is the right side of the graph. Negative infinity for x is the left side of the graph. So this top line is asking for the right side, and this bottom is asking for the left side. And end behavior predicts where your y values go. Remember that this is y, or f of x. So you're going to tell me, does it point up to positive infinity or does it point down to negative infinity? End behavior predicts the y values. So up or down. And then remember that asymptotes are lines that a graph will approach but never touch. Exponential functions, log functions, and tangent functions have asymptotes. We didn't really talk too much about tangent, but an exponential function is going to be y equals a number, and a log function is going to be x equals a number. So let's talk about all of our families of functions. So I'm going to start off with some of our basic parent functions and give you some general characteristics that you should know about these. So a linear function is obviously a line. Its parent function is f of x equals x. The domain is always going to be all real numbers, as well as your range. And remember that all real numbers is negative infinity to positive infinity. Key things to know is that it has a constant rate of change. And when you think a linear function, you should think of an arithmetic sequence. Y equals mx plus b is oftentimes used for linear functions. B is your y-intercept, m is your slope, or your rate of change. So your y-intercept is your fixed value if we're talking about a word problem, and your slope is what's changing every single time. So a quadratic function, our parent function is f of x equals x squared, and it's a U-shaped graph called a parabola. Your domain is always going to be all real numbers, and your range is going to be the minimum to infinity. Or if it's a reflection, it's going to be negative infinity to your maximum. Key features or things to know. So this is y equals ax squared plus bx plus c is our standard form of a quadratic function. And in this case, c is your y-intercept. Now, a quadratic function is actually part of the polynomial family, but it has some specific features that we talk about. Polynomials, in general, are ax to the fourth plus bx to the third plus and so on. And it doesn't need to be the fourth. The fourth is a quartic polynomial. It could be to the 10th. It could be to any power. So depending on the degree, remember, the degree determines the shape. And we talked about that already in our previous review videos. So it could look something like this. That would obviously be an odd degree because my arrows are pointing in opposite directions. Your domain is always going to be all real numbers. Your range is going to depend on the graph or the function. It doesn't have a general form. Remember that your leading coefficient is always going to determine your right arrow, which way it's pointing. And then odd degree is opposite. And even degree is the same. So those are our polynomial functions. Let's move on to our exponential functions. So an exponential function, f of x equals b to the x power. So for example, y equals 2 to the x, or y equals 3 to the x, something like that. If it is increasing, it's going to look like this. If it's decreasing, it'll go in the opposite direction. Your domain is always going to be all real numbers. Your range is going to be your asymptote to infinity. Your asymptote is always going to be y equals your vertical shift. So in the parent function, it's y equals 0 because there's no vertical shift. It's going to have no x-intercept unless, of course, there are shifts. Your y-intercept is going to be 0, comma, your initial value, which is a, plus your vertical shift, which is c. So in actuality, up here, when I have f of x equals b to the x, it's really going to look like this when I write my formal notation. It has a percent rate of change, and you should think about geometric sequences. And these two functions are next to each other, which is important because they are inverses of each other. So next up, we have the log function. So our log function is going to look something like this. Let me go back over here to my exponential and I'll draw in my asymptote here. My asymptote is horizontal always. For log, my asymptote would be here. It's always going to be vertical. So it's going to be x equals your horizontal shift. So our general equation is going to be f of x equals log base b of x. So for example, y equals log base 2 of x. Your domain is always going to be your asymptote to infinity, and your range is always going to be all real numbers. There's no y-intercept unless there are shifts, and your x-intercept is 1, 0 unless there are shifts. Sine and cosine function looks like this. That, of course, is sine. Cosine starts the maximum, but we will go more into that next week when we talk about trig. So I have a cosine bx plus c, or y equals a sine bx plus c. Domain is always all real numbers. Range is always -1 to 1. This is known as a periodic function, which means that it repeats on a set interval. So these 6 functions you need to know very well. That's why I have a lot of key features. We've talked about intercepts. The next few you should just recognize, but we don't go as detailed into as much detail as the others. And those are your square root function, which looks something like this. My domain is 0 to infinity. My range is also 0 to infinity. And my parent function is radical x. The cubic function is x cubed. It's a polynomial function, a specific kind, just like a quadratic. So my domain is all real numbers. It is odd. So my arrows point in opposite directions, so the range is also all real numbers. These two functions are also inverses of each other. Nope, sorry. Inverses. I jumped the gun. These two are inverses of each other. Because now I'm going to do the cube root function, which is going to look like this. My domain is all real numbers, as is the range. Okay, so now we have graphing functions in general. So we always start by hitting zoom 6. That brings us back to our original window. This is the 10 by 10 window, and that's where we start. You always copy down a table from your calculator. And remember, to get to table, we hit second graph. Make sure we label the axes by what we're counting by. We always want to put arrows on the end unless you're given a specific domain. So a specific domain would say on the interval from -1 to 3 or something like this. And then my table would just be those values, nothing else. It would be my starting point and my stopping point, and there would be no arrows. Otherwise, I have arrows. If they give you specified X values, like we just talked about, you're going to set the window for your X min and your X max first, and then you're going to hit zoom fit, which is zoom 0. Remember the difference between the directions on a question. Graph means you need a table of values and plotted points. If it's a log or an exponent, you also want to include your asymptotes. If it just says to sketch, you can have the general shape of the picture. You do not need specific points. That's really important to know the difference in those directions. Systems of equations. A solution to a system of equations is x comma y because it graphically represents a point or points of intersection. A solution to f of x equals g of x is the x values only. And you can still solve it as a system, but I'm only looking for the x value because technically it's an equation. All of your calculator tricks are outlined for you here. The big thing is second trace 5. Those are your steps for finding a point of intersection. A conic linear system of equations, what does that mean? It's a circle and a line. Okay, a circle is x squared plus y squared equals a number. That's how I know it's a circle. So in order to solve a conic linear system of equations, you're going to solve the linear equation. So it either says x equals or it says y equals. And then you're going to substitute that into the circle equation. So for example, x equals 3 plus y, x squared plus y squared equals 5. You're going to take this and substitute it in for x. Then you are going to solve the equation for the remaining variable. Most times you're going to need to do the box method. And exactly that, you're going to make sure to use the box method when necessary. Sometimes you'll need to use it more than once. Remember to always go back and plug back in to find the other variable. If you find 2 x's, you need 2 y's. A 3-variable systems of equations. I'm not going to read through all these steps. You have them to read through on your own. But remember, a system of 3 variables is something like x plus 7y minus 3z equals 5, and there would be 3 other equations. So remember that all of your variables need to be lined up in the same order. So if I'm solving something like this, I would need all the x's, y's, and z's on the left side and all the numbers on the right side. And you need a placeholder whenever necessary. So for example, in this last equation here, I would need to write this as x minus 4y plus 0z equals 7 before I went to use my calculator to solve. Average rate of change. So this is a very popular question that comes up both as a free response and as a multiple choice. Average rate of change is the same thing as slope, which means it is the change in y over the change in x, or y2 minus y1 over x2 minus x1. If they give you an equation, you're going to type it into y equals, go to the table, copy down your coordinates, and then you're going to substitute into that formula. If they give you an interval, it is x values that they are giving you. For example, if they give you find the average rate of change on the interval -3 to 5, those are the x values that I'm looking for. I'm looking for the corresponding y values in my calculator, and then I'm plugging into the formula. Inverses. The symbol for inverse is f to the -1 of x, f inverse of x. Your domain and your range are switched. Your following functions are inverses of each other. We talked about this a little bit as we did the families of functions. Linear and linear. Quadratic and square root. Cubic and cube root. A rational function, which is a variable in the denominator, something like 1 over x or 5 over x plus 2. The inverse of a rational function is a rational function, exponentials, and logs. So in order to do this, we switch x and y. So your multiple choice trick is to type it in your calculator, switch your x and y, match the tables. If you happen to remember the information that I just put up above with linear and linear, it can help you eliminate some answer choices. The other thing is that linear is always going to be a reciprocal slope. Square root is always going to be a plus and a minus. So that may help you eliminate some answer choices as well. Regression. Regression is when I give you a table, x, y, and there's some numbers in each of them. You're going to type it into your calculator, stat edit, all the information, stat calc. You have to go to the right to get that. And you're going to choose the model based on the question. They'll say exponential regression or linear regression. Exponential is the big one that comes up most often. It is extremely rare that they give you a scatter plot, but in case they do, here are some pictures below. Linear is choice 4, like I have written up here. This is exponential, which is choice 0. This is quadratic, which is choice 5. The next is logarithmic. This is the one that looks a little strange. It's choice 9 because it's the natural log, ln. And then sinusoidal. But remember, they do not ask this most times. They give it to you in a word problem, and they're telling you to calculate a specific type of regression. You just need to read correctly. And that's it.